Okay, Assalamualaikum and good evening to everyone. My name is Danish Ikwan bin Sadid with matrix number 230482. So today I'm going to set up an x86 assembly language, programming environment and debug an assembly program. So first thing first, as you can see, I already installed the SASM. And then for the starting, after we install the SASM, we go to the settings. We make sure that mode and assembler we set it as x86 and ASM before we run any project. Okay, and then after we already confirm the settings build, we can up we can load the average for file. Okay, so this is the assembly coding. So I will explain line by line. But first, before we go to the coding, we need to build this first. Okay, build successfully, and then we go to the debug. Okay, so see, we can see the register here, and then for the memory, we need to add two variables, which is first is data, and then we go change from smart to hex, and then from data to word, from D to W, and then we set the array size as 4. Okay, so we see the about x1 or x2 or x3 or x4, and then the second variables is result. Okay, in result we set it as hexadecimal, and we also set it as W, and then for array size we set it as 1. And then now we can go to the assembly coding. So first you can see the line 6. It says that move EBP ESP. So this is for the debugging code, debugging instruction, so it's okay. And then we go to the step over button, and then we go to the step over. You can see the EAX. So what is EAX subtraction? For this is for to clear the register AX. As you can see, in EAX we have 1 in info, but after we click the step over, it turns out as 0. So that is the function of the subtraction EAX. So then we go to the move ECX 0x04. So the function is to set counter to 4. So we in this line it says ECX, so we can focus in the register ECX. After we step over it, we can get the info, turns out to be 4. So in move ECX, we load the value 4 into ECX. So this acts as a loop counter since there are 4 numbers to process. So next we go to move ESI 0x08. So we set the ESI to 8. So this is for as an offset to point into the data array. So we step over again, and then we enter in AW loop. So AW is a loop, we define it. So every time we go to the loop, it will jump to decrement ESI. So the function of the line 12 is decrement SI by 1. So we focus in ESI in the register. It says 8. So after we step over, it will decrease to 7. And then we step over it again, we decrease to 6 because we decrement it twice, 1 and 1. Then we got ESI as 6. And then for the line 14, you can see the command says it add number to register AX. So we focus to AX register. From 0, we'll change to all the sum of 4 numbers. So the sum of the 4 numbers is 16,384. And then if we step over it, it will jump to line 12 again, because as you can as I said just now, we set the counter to 4, which means we have a 4-time process. Okay, the value changed to 28,672. It changed again to 36,864. And then the final answer, the final result of the loop, we got 40,960. And then we'll go to the sub EDX EDS. So it is the same function as sub EAX, but now we focusing on the register EDX. So subtraction EDS it will clear the EDX register. See, it's already turns out 0. And then we move CX to set the divider to 4 data. See, the ECX it will turns as 4. So it will loads CX to 4. This is the divisor since we want to average of 4 number. Yes. Okay, and then we go to the move DS result to store the computed average into the memory location labeled as result. So in this line, we use the macro to print the result in hexadecimal format, showing 2 digits. See, 2 8s, and the outputs already show out 2,800. And for the next line, we press for system call to exit by placing the exit code into EAX. So move EAX to exit. And then for INT 0x80, it triggers a software interrupts to call the Linux kernel, which is execute the exit system call. So we'll already end the program here. So you can see that this is the end. That's all for me. Thank you.